Slope is how steep a line is. If a line is flat, how steep is it?
Not steep at all.
No,
Not
it's
steep at
zero,
all.
zero slope.
Steepness. If a line is straight up and down, how steep is it?
Undefined.
Undefined, because it's not where you can't really say it's up or down, right? Because slope is read left to right. So if you're reading across the graph and you hit a vertical line, it's undefined slope, okay? So think of this as a road that you drive on. Now, slope always has two components to it, a height difference and a width difference, okay? So in this one, we would say that this, if we're going from this point to this point, you go down how many?
3.
2.
Oh, 2, yeah.
3 marks, but how many spaces?
2.
2. Yeah, so
Oops.
we count on a graph, we count how many spaces we've traveled. So this is down 2, okay? So we show that as a negative 2. How many spaces over am I going?
1.
Okay, so over 1. So the slope is down 2 over 1, okay? We tend to show slope as a fraction. Now you guys know that you don't have to write over 1 technically, right? Because dividing by 1 is just the same. But when we're doing slope, that kind of helps us see the relationship between how far we go down compared to how far we go over. So writing slope as a fraction really sometimes helps.
So,
Okay? So this would be a slope of negative 2, but negative 2 over 1 is a fine way to show it. Okay?
That's
Now, if I wrote
that's
this
how you
in
graph
equation,
it.
this equation would be y equals negative 2x plus 3. Y plus 3.
Until you got 1 left, because you add 3.
It's-
So there's 3 spaces up.
It's 3 spaces, it hits the y.
Yeah, this has nothing to do with slope, actually.
That's where it hits the Y.
That's location on the line.
Um,
The steepness of the line isn't a location. It's a quality that's the same everywhere on the line, right? It's just that it's easiest for us to measure the slope from a location that we already know. So that's why that's kind of
So
important.
the 3 is for what? To do.
Where it crosses
Okay.
this
Oh, yeah,
y-axis. This is a y-axis, right?
Yeah, okay.
So wherever it crosses that, basically it shifts the line up or down, and this one shifted it up 3.
Yeah.
Right? So this gives us location, and this tells us how steep it is. So if I'm drawing this line and I don't have a graph and I want to graph it, I'm going to start at 3, and I'm going to go down 2 and then over 1 to get another point. Okay.
Yeah.
So that's how slope works in this problem. I want to do the visual one first, okay? Now, if you just have 2 points, you could graph them and then do the visual thing. Okay, count down and over, or up and over. But there also is a slope formula, so if you don't have this written down, you should write it down and kind of memorize it. You subtract the 2 y values and put that on top, that's your change in height. And then you subtract the 2 x values and put that on the bottom, that's your change in width. Okay? Remember, slope is 2 components, change in height and change in width, in order to get a diagonal line. Okay? So y take away y. I usually just subtract down, and if you start subtracting down, you have to subtract down for the x's too. So 8 take away a negative 2 is what?
10.
Positive 10, because these negatives will become a plus, because it's removing a negative. So that's actually plus. Okay? And then 3 take away 4. What's that equal? Negative 1. So the slope is negative 10, yeah, because that just simplifies to a minus 10. So you could write it as this. That's down 10 to the right 1.
Wait, why is the top negative not?
Yeah, so if you go up 10, left 1, you get the same thing. Okay? So think about it this way. If I have a line like this, if I were to go up 10 and left 1, it's the same as going down 10 and right 1.
Okay, yeah.
Make sense? But typically we would have the negative on top of a fraction. Usually on a fraction, that's just customary that the top gets the negative. Okay? So that's a formula that you need to know. The slope formula for finding even 2 points. Okay? So you really need to memorize that. What's the slope here?
3.
3.
Yeah, how do you know?
Y equals mx plus b.
mx, y equals mx plus
Yeah,
3.
if it's in this form, y equals mx plus b. Okay? So we have So I have y by itself, and then a number in front of x. M, the number in front of x, is always the slope. So this is probably the easiest question. Do you just look in front of x and you see it's 3? Yay! And that's the slope. If I wrote this as a fraction, what would it be?
3 over 1.
3 over 1.
Yeah, up 3 over 1. Okay, so this line is going uphill. Okay, so that's the slope of that one. Now moving over here. Is this in slope-intercept form?
No.
No,
So it would
I
be
wish it
wrong to
was.
say, well, the number in front of x is 2, so therefore the slope is 2.
it's
It's not
not.
the case, is it?
That was the hardest one.
Yeah,
It
this
just
is
took a
harder
lot of
problem.
algebra.
So we do have to kind of like do a little bit of what are they called when you add to both sides? Equality properties?
Equality properties,
Okay,
yes.
so we have to do some equality properties. So I'm going to do subtraction property of equality here. Subtracting x on both sides. I'm trying to get y by itself, so it's in slope-intercept form. So I have negative 3y equals negative 2x plus 6. So since there's no sign in front of it, it's a positive 6. So we can put a plus 6 here. Okay, is y by itself?
Mm-hmm.
Yeah.
It's kind of, the y term is by itself, but I need a 1y rather than a negative 3y. How do I get a 1y here?
Divide by
Divide.
3.
Divide everything by negative 3.
Oh, okay.
Okay, so I have y equals 2/3 because the negatives are going to cancel. And then what is this?
Negative 2.
Yeah, minus 2. So it crosses at negative 2, but the slope is 2/3, right? So up 2 to the right 3. Okay, so if I were graphing this, I'd go from here, which is a location, oh no, not from there. From here, which is a location I know, up 2 and over 3. So my line is there. Up 2 and right 3. Okay, and that's how I graph a line. And that's a review of slope.